So similar to amino acids, nucleotides contain nitrogen and must be degraded in a manner that allows for proper nitrogen disposal. So the fundamental process for both purine and pyrimidine involves dismantling the sugar, the phosphate, and the base structure into their respective units. And in the case of purine degradation, the base is excreted as the end product, uric acid. So here you can see that in the case of adenosine, it can be deaminated to inosine. And both inosine and guanosine can be converted into their respective bases by a nucleotide phosphorylase. So these respective bases, hypoxanthine and guanine, can both be oxidized or, in the case of guanine, deaminated to xanthine. And xanthine can be further oxidized to generate uric acid. Uric acid is then typically excreted in the urine. So what's important to note about uric acid is it's not highly soluble, and elevated levels can precipitate and cause the clinical presentation of gout. So excessive uric acid again causes hyperuricemia, and the precipitation of uric acid typically in the joints elicits an inflammatory reaction that causes acute pain. So to reduce amounts of uric acid from purine degradation, we have several salvage pathways. So again, the ability to recycle nucleotides, specifically in the case of purines, is important. So to assist this, we can then instead take our bases and convert them back into nucleotides. And there's two primary enzymes here responsible for these conversions. The first is adenine phosphorybosyl transferase, and the second is hypoxanthine guanine phosphorybosyl transferase. And this enzyme is responsible for the reactions with both hypoxanthine and guanine to generate our nucleotide monosphosphates. So in all cases, these enzymes will recombine our free base with our activated sugar PRPP. And what we'll see is that deficiencies in these reactions can result in the clinical presentation of gout or other clinically relevant symptoms. So we're going to finish this by looking at several scenarios which can result in the presentation of gout or hyperuricemia. And this can really present due to decreased salvage of purines, overproduction of purines, or under-excretion of uric acid. So we'll focus on decreased salvage as well as overproduction, as these are both scenarios that we've addressed in the course. So to start, Lesch-Nyhan syndrome is characteristic of a deficiency of the enzyme required for purine recycling, and that's hypoxanthine guanine phosphorybosyl transferase. So in this case, a deficiency in the ability to salvage our purine nucleotides results in accumulation of uric acid. In addition to the presentation of gout and joint inflammation, there are a whole other host of neurological symptoms associated with this syndrome, and it's unclear for many reasons why those also are produced. So second, elevated uric acid can present because of an overproduction of purines. And if we go back to our synthetic pathway illustrated here, the pentose phosphate pathway that generates our ribose 5-phosphate required for the synthesis of PRPP, our activated sugar, this becomes fairly clear as to why this is the case. So in von Gurk's disease, remember, this is a deficiency in glucose 6-phosphatase. So glucose 6-phosphate, either produced through gluconeogenesis or glycogenolysis, is trapped in the cell. As such, that substrate has two fates. It can either be oxidized through glycolysis or through the pentose phosphate pathway, and that will greatly increase our production of ribose 5-phosphate. And an increase in ribose 5-phosphate can then lead to an increase in our purine bases. So again, in this case, it's an increase in substrate that leads to an increase in our activated sugar from ribose 5-phosphate to increase nucleotide production. So our final presentation of gout can be caused by underexcretion of uric acid. And the primary example for this is in cases of excessive alcohol consumption. And in this case, we haven't talked about alcohol consumption or alcohol metabolism. So I'm not going to add this to your plate right now. But if anyone's interested, here's a great reference for it. Essentially, alcohol consumption increases production of lactic acid, and there's competing excretion for lactic acid and uric acid. But instead, let's note that the presentation of gout has been characterized for quite some time. And this is an excerpt from a New Scientist article that suggests that they've now found dinosaur remains with indications that even dinosaurs suffered from gout. I'm not really sure whether gout made them grouchy, as the article suggests, but it is an interesting clinical correlate. And finally, I'll leave you with this last thought. So treatments for gout caused by hyperuricemia particularly target the xanthine oxidase enzyme. And xanthine oxidase inhibitors will inhibit the activity of this enzyme and then therefore reduce uric acid production. And an example of this would be allopurinol. So allopurinol will inhibit xanthine oxidase and reduce uric acid production. And xanthine, the intermediate here, is soluble. So soluble xanthine is then eliminated much easier than our uric acid. And I'll leave you with that final thought. And again, this is week 15. It's been a pleasure working with everybody. And please let me know if you have any questions as you finish up the last few pieces of the course.